Hello everyone, welcome to the channel. My name is Munira and I am a class 10th student who loves science and mathematics. On this channel, we'll learn concepts together in a simple and easy to understand way. Today's topic will be electronic configuration, and by the end of this video, we will be understanding what is electronic configuration, why are electrons arranged in different shells, and how to write electronic configuration for different elements. So let's begin our chapter. First, what is electronic configuration? Let's first understand the meaning of the term. Electronic configuration simply means the arrangement of electrons in different shells around the nucleus of an atom. These electrons do not stay randomly around the nucleus. They are arranged in a specific way in different shells which surround the atom, like this. These atoms are arranged in specific energy levels called shells. These energy levels are called as shells. Right now, think of a building. A building has different floors. Similarly, an atom has different shells where electrons stay. Okay, so the atoms are surrounded by electrons. These electrons are not just randomly lying here and there. Instead, there are some orbits on which these electrons are present. And there are many different orbits such. So these orbits are called as energy levels, and these energy levels are referred to as the shells. Now we will discuss about the shells of an atom. There are four main types of shells: the K shell, L shell, M shell, and N shell, and so on. Each shell holds a certain maximum number of electrons. Okay, so the formula that we use is 2n square. I'll tell you how can we find out the shell. Okay, when we look at this formula here, n represents the number of the shell. Number of the shell. How? As you can see, this is the atom. The first shell or the first orbit is the K, then followed by L, M, and N. So K is number 1, L is number 2, M is number 3, and N is number 4. So when we say N, number of the shell, so we mean if it is referred to K, then 1, then L, 2, M, 3, and 4. So we can determine the number of atoms using this formula. The number of electrons in each shell using this formula. For example, if you want to know how many electrons are there in the K shell, then we can easily use this formula 2n square. 2 into K is the first shell, so 1 and square, so that will be 2. So 2 is the number of electrons present in K shell, and it is the maximum number. It is the maximum number of electrons that can be present in the shell. Similarly, if you want to find out how many electrons are in the L shell, it is the second shell, so 2 into the value of n will be 2 because L is the second shell. So 2 and square, so that will be 2 into 4 equals to 8. So the maximum number of electrons in L shell is 8. Let's check for M shell. So 2 into, I'm directly putting the values, 3 square, so 2 into 9 will be 18. Fine. Now for the N shell, 2 into 4 to the power 2, so 2 into 16 will be 32. So 32 electrons are in N shell. Now we know that in K shell the maximum number of atoms can only be 2. maximum number of electrons. In L shell it can only be 8, and in M shell it will be 16, and in L shell it will be 32. So the maximum number of electrons in each of these shell is written here. Now one thing to note is that whenever we write electronic configuration, we will always take the maximum number of electrons for M and N shell also to be 8. Now let's learn how these electrons are filled in the shells. First of all, let's take the example of hydrogen. We will be needing the atomic number of elements during electronic configuration. So the atomic number of hydrogen is 1. First we make a table where we divide it into 4 shells, K, L, M and N. Now we write our element and we start filling this table from the innermost shell. So electrons always fill the inner shell first. Only after a shell is filled do electrons begin to enter in the next shell. Like thinking of filling water bottles, you fill one bottle first before starting the next one, right? Similarly, we will fill the K shell first. Okay, so there is only one electron right here. So the electronic configuration for hydrogen will be this. Okay, and if you have to make a diagram, then you can make it like this. Okay, now let's move on to some more examples. So the electronic configuration of hydrogen was 1. Now let's see the electronic configuration of helium. Now let's see the electronic configuration of helium. Atomic number of helium is 2. So using the same table, we will fill the table from the innermost, as I already told you. K shell can only hold 2 electrons, right? So helium has 2 electrons, so we'll directly write 2 here. Now we don't have any more electrons left with us, so the electronic configuration for helium will be 2. 2 will be its electronic configuration. Fine. Now let's see for oxygen. So atomic number of oxygen is 8. So the number of electrons is also 8. I'll tell you, number of electrons, the number of electrons is equal to the atomic number. Fine. So for oxygen, the atomic number is 8. So the number of electrons will also be 8. Let's make our table K, L, M, N. Right, I'm making lines this time. Last time we did not make any lines. Okay. So in the first K shell, the maximum number of electrons were 2. So we'll write 2 here. Now we will move on to the next shell, because this shell is full. In the L shell, we will write the remaining electrons, but note that only 8 electrons can come in this shell. So we have 6 electrons left, so that will be fine. We can write 6 electrons. Okay, so the electronic configuration for oxygen will be 2, 6. We always write the electronic configuration using commas in between numbers, and if we have to represent it using diagram, then we will write oxygen in the middle or the symbol of the element, then make the number of shells that it is filling. It is filling 2 shells right here, so we will make 2 shells, and in the first shell there are 2 electrons, so we will make 2 circles for electrons in the first shell, and in the second shell we will make 6 electrons. 1, 2, 3, 4, 5, 6. So this is how we can make the diagram. Okay, represent it using a diagram. Let's see one more example. This time we will be seeing sodium. So the atomic number of sodium is 11, right? So the number of electrons is also 11. Let me just erase this extra line. Yes. So the number of electrons is also 11 when we will make the table now. And start filling this table. Okay. So first, in the first shell there will be 2 atoms, in the K shell 2 atoms. Next we have 9 atoms remaining, which means that only 8 can come in the L shell. Why? Because the maximum number of atoms that can come in L shell is 8. So the 1 electron that is remaining, we will write it in the M shell. So the electronic configuration for sodium will be 2, 8, 1, and you can represent it with using a diagram just like how we did for oxygen. You have to make one more shell and represent the number of electrons in each shell. Now, why is electronic configuration important? So let us discuss now what is the importance of electronic configuration. Okay, first thing first, it helps us in understanding valency, and it helps us in finding out the valency of different elements. Next is it helps us in understanding chemical bounding. Then reactivity of elements is also determined by its electronic configuration. Okay, so and the position of elements in periodic table is also according to the electronic configuration. So these are the 4 topics which electronic configuration explains. Without understanding electronic configuration, many chemistry topics becomes difficult. So make sure you understand the chapter thoroughly. Now for a quick recap, electronic configuration means arrangement of electrons in different shells. There are 4 types of shells: K, L, M and N. Maximum number of electrons that can fit in K shell is 2, in L shell it's 8, in M shell it is 18, and in N shell it is 32. However, we assume these last 2 to be maximum 8. Okay. Next, for whenever we are writing the electronic configuration, we always fill the first shell first and then move on to the next shell. We discussed some examples of hydrogen whose electronic configuration was 1. For oxygen, discussed for oxygen whose was 2, 6. We always use comma. Okay. Sodium, next we discussed sodium. So for sodium it is 2, 8, 1, and to represent it using a diagram, we use the element in between. We put the element in between, then we make different shells, then we fill it with electrons like this. This is a very important part, and sometimes it comes in your exams to make the diagram for electronic configuration. Okay, so making the table as well as this diagram is very important. Even if the diagram is asked, you can make the table. It will help you in exams. Okay, so that's the basic idea of electronic configuration. If this explanation helped you understand the concept, make sure to subscribe and join me as we explore more science and mathematics topics together. In the next video, we will be learning about valence electrons and valency. Thank you for watching and keep learning.